So in this video, we'll be talking about plastics. So yeah, that's just the introduction. Um, this is module 12 for, this is the last lesson basically for our fourth long exam. I skipped the module 11, that's the one in between um, metallurgy and this. I'm not sure if I'll be able to make a video on that. We'll see. Let's start already. So polyester is used in clothing fabrics, so it's easy to wash and dry. Polyester is when an ester functional group connects the monomers. Just give me a while. Let me see if this is the right file. Yeah, I think this is where we actually start. Okay. One example of polyester is PET. More on this later. What that abbreviation means. Polyester also is known to blend well with other fibers. That's why usually when you look at how some clothes are, well, basically what their compositions are, sometimes it says a specific percentage of polyester and a specific percentage of other fibers such as cotton and wool. So polyester is one of those fibers that are synthetically made. They're not naturally made, unlike cotton and wool. Okay, so let's start with the various kinds of plastics that okay, so we have HDPE, PVC. I don't think this is the right way to introduce them. So HDPE is high density polyethylene. Just give me a while. Yeah, this is actually how we start the lesson. Okay. High density polyethylene is one of the safest forms of plastic, out of the 6 at least. The 6, by the way, we call them the 6 big polymers, I think. I'll fact check that later. But essentially, HDPE is known for being reusable and recyclable. They are durable, they have high melting points. That's the reason why some furnitures are made out of HDPE. And yes, they don't leach into chemicals. They don't leach chemicals into liquids and food that it contains. So yeah, it's very popular to recycle HDPE. For PVC, in other words called that's annoying, polyvinyl chloride, it can be further softened into plasticizers. This is the material that's used to make the tubes for blood bags. In a way, I think you can imagine that they are the blood vessels. So let's say you want to transfer blood from the bag to, in the scenario where someone is donating blood, the tubes are made out of polyvinyl chloride. So the blood gets transferred through this tube to the blood bags. Okay, so artificial leather is also made out of PVC. You can call PVC as poison plastic because unlike HDPE, PVC actually leaches chemicals. So it's toxic basically. Okay, so on top of that, less than 1% of PVC materials are recycled. So this is what a monomer of PVC looks like. So chlorine over here, double bond, and then hydrogen atoms everywhere else. So PVC is one of those polymers that are made using addition polymerization. So during the reaction, PVC can be arranged in three different ways to create a polymer. So we have head to tail, head to tail. This is the most common, by the way. We have tail to tail, head to head, and random. And okay, that's it for PVC. Next is LDPE, or low density polyethylene. So this is used in cling wraps, garment bags, squeezable bottles, and soft plastics. One thing you have to know though is that LDPE, in comparison to HDPE, this cannot be microwaved. Plastics that are made out of LDPE usually, because they have a a really low melting point in comparison to its counterpart HDPE. When you microwave, uh, well, it basically decomposes physically, so it's not ideal to use. It is less toxic compared to other plastics. It's not commonly recycled. If ever you recycle them, it turns into plastic lumber, plastic boards, floor tiles, etc. When you recycle them, LDPE is not as hard as recycled HDPE. So, in a way, I think you can say that LDPE is easier to recycle. Although, again, it's not common. What I said about LDPE being easier to recycle, that's actually not fact checked, okay? It's just basically my synthesis based on what's based on its one characteristic, that is that it's not as hard as HDPE. So yeah, LDPE is reusable, but again, it's not always recyclable. Okay, I think this is actually supposed to be the first page. Anyways, we're already here anyways. Polymer branching can also alter physical properties. So, one example, one application to this is polyethylene. So there are two different types of polyethylene. I've already mentioned this in the first page. HDPE and LDPE. The only difference is in terms of its density. So HD meaning high density, LD meaning low density. So what's the difference? HDPE has high rigidity and strength, and it has a high melting point. Unlike in LDPE, in its case, it's a more highly branched form of PE or polyethylene. Consequently, it has a lower melting point. For HDPE, they're basically linear polymers that are tightly stacked on one another. This is what it looks like in illustration form. So basically, the intermolecular forces are stronger. So this is usually the kind of material you use for the production of milk jugs, bottle caps, and toys. For LDPE, they have empty spaces in between the polymers. So yeah, consequently, the intermolecular forces are weaker. This is what it looks like in illustration form. And low density polyethylene is usually used for the creation of plastic bags, plastic films, and for electric wire insulation. So yeah, like I said earlier, the big six polymers, we've already actually tackled three of them. Polyethylene, the low density and high density types, polyvinyl chloride, it's abbreviated here as V, although you can also abbreviate it as PVC to be complete and to be safe. Also polystyrene, polypropylene, PP, polyethylene terephthalate, or PET. Sorry, this has been mentioned earlier actually, if you recall. It's an example of a polyester, I think. Yeah, there. Polyester example PET. So, out of the 6 big polymers, not all of them are recyclable or reusable. Based on what's already been tackled a while ago, it's already been clear that in the case of HDPE, you can recycle, you can reuse. For polyethylene, you can reuse, but recycling isn't common. For polyvinyl chloride, what did it say again? Less than 1% of PVC materials are recycled, so almost not at all. And based on the fact that it's a poison plastic, that means toxins can leach through. It's not exactly ideal to be reused. So yeah, that's for HDPE, LDPE, and PVC. Out of the 6, polyethylene, low density polyethylene has the lowest melting point. So you can say that when you microwave, avoid LDPE the most. You try to avoid low density polyethylene the most. So 3 polymer materials that are used most often when you need a more flexible polymer. They're encircled in red. So we have LDPE, HDPE, and PET. Recyclable plastics, we have LDPE, HDPE, polypropylene, and polyethylene terephthalate. So basically, what's not recyclable are PVC and polystyrene. Polystyrene, by the way, I'll just spoil it to you already. Also, we'll tackle it formally later in this video. It's basically styrofoam. Before, at least in the Philippines, fast food chains, at least specifically Jollibee, they actually used to use styrofoam to contain takeout orders. So your burger steak, your palabok used to be, for as long as it was takeout, it was housed by polystyrene containers. So it was dangerous in various ways. More on that later. Let's talk about PET first. Polyethylene tetraphthalate. It is recyclable, as mentioned earlier, but it's not reusable. Tetraphthalate, the phthalate, the word phthalate, is known to be an endocrine disruptor. So usually it's intended only for single use because there is a high risk of leaching. And at the same time, studies have suggested or have shown that PET is carcinogenic. So the maximum times that you can use something that's made out of PET, especially when it contains something that you consume, such as drinks, you only use it at a maximum of 2 times, but ideally just don't. So when you recycle PET, it has to undergo something called shredding. So you reprocess to make new PET bottles. An application to PET, I think it's already implied, bottles are made from PET, aside from HDPE that make milk jug bottles. If they are not reprocessed to make new PET bottles, they can be spun into polyester fibers for the purpose of making textiles. So carpets, I think that counts. What stuffs? Pillows. So pillow stuffing. I think that's. I'm not sure how it's formally called, but I think you get the idea. What stuffs pillows? And yeah. This connects to what's been mentioned earlier, that PET is an example of a polyester. So yeah, upon recycling, it can become polyester material. So yeah, textiles such as clothing, that kind of sort. The copolymers of PET, we have ethylene glycol and terephthalic acid. You use it in for the production of beverage bottles. For what properties? What makes PET, although having these characteristics, being carcinogenic, having a high risk of leaching, which makes it dangerous for human consumption, through the containers that are made from this kind of material. Uh, so good characteristics are they are semi-rigid, they are colorless, and they are gas tight. So yeah, another way um, of, well, you can't really call it recycling, but aside from recycling, you can downcycle PET. So this is when PET plastic is mixed with other plastic materials. So more on this later. When it comes to discussing the 4 Rs, 3 of which are reduce, reuse, recycle, something that's very familiar to you, definitely. Okay, so we have polystyrene. Polystyrene is cheap. Oh wait, never mind. Let's talk about polypropylene first. It's at the very top. Abbreviated as PP. It is from propylene, a common name of propene. It is strong, tough, lightweight, and it is able to withstand high temperature. It serves as a barrier against moisture, grease, and chemicals. So this is one advantage. Also, they are recyclable and reusable, just like HDPE. So polypropylene, usually what's made from it, we have microwavable containers. Because plastic polypropylene doesn't melt. Again, it's heat resistant. It can withstand high temperature. But PP can release hormone disruptors, just like PET. So it's still technically not recommended to microwave polypropylene. If you want to be really safe, you can just use something that doesn't release hormone disruptors. Glass containers for food, metal containers perhaps, that kind of sort. So aside from microwavable containers, what's made from polypropylene are disposable diapers, pails, plastic bottle tops, potato chip bags, yogurt containers, washable bottles, so that kind of sort. Let's move to polystyrene. So it is cheap. It is also formed through addition reaction, addition polymerization. I think that's the case. It is described to be naturally transparent thermoplastic that is available as both typical solid plastic or a rigid foam material. So it breaks up very easily. It gets dispersed throughout the natural environment, which makes it it does give an implication in how it becomes a problem to the environment. So it actually contributes to microplastic waste, and it did make sense. The reason why fast food chains in the Philippines before used to use polystyrene for takeout containers, now they don't. Now they use paper, wood-based containers. Kind of because of this. It's very lightweight. It's normally hard. One major disadvantage, just like PVC, as well as PET, and somehow just like polypropylene in a lesser extent though, because it doesn't fare as bad as PVC and PS or polystyrene. It does leach styrene to food. Styrene is a known carcinogen. Okay, you have to know that. Recycling, polystyrene, it's not widely available, although it exists. The market is just pretty small for polystyrene recycling, and you can reuse it depending on the material. So more practically, in the sense where, because you have to know, polystyrene, it's actually the material that composes your laptop cases, your CD cases, your phone cases. So you can reuse these things basically. So that's what I said when I said reuse depending on the material. Not everything could be reused that's made out of polystyrene, but there are exceptions. This is one of them. So in the monomer, this is what it looks like: polystyrene, H everywhere, carbon, and then I'm not sure what this is called anymore, but yeah, that's what it looks like. Expandable. We have another kind of polystyrene. Technically, it's called EPS. E for expandable. So this is the kind of styrofoam in fast food containers. So foamed plastic. So essentially, usually pentane is used as a blowing agent, sometimes carbon dioxide. But before though, actually, oops, CFCs or chlorofluorocarbons were actually used as blowing agents for EPS. As a result, um, well, since it's been popularly used in the fast food industry, so whenever you see kids destroying styrofoam, when you puncture holes in styrofoam or basically foamed plastic, CFCs are actually released. So that's basically not good for the environment. So in a way, CFCs were banned as blowing agents for EPS. Um, it was kind of replaced with CO2. I'm not sure if pentane is still used now, or if it has um, sustainability benefits, or if it contributes to sustainability as much as CO2. But CO2 is actually a good substitute. CO2 for EPS production helps because it tries to consume CO2 that we produce. So in a way, it does reduce greenhouse gas emissions. But polystyrene itself is already dangerous to the environment and humans. So in a way, I think one synthesis to this idea is it's better that we avoid polystyrene. Maybe not to an extreme where we don't use it at all, but you just have to be aware that it's not good for the environment. So even if you use CO2 for EPS production. So what are these blowing agents? They basically vaporize when slightly heated, so they expand the polymer. That's why it looks like foamed. It looks foamed. So yeah. That's it. Next. The 4 R's. Okay, we're here now. Um, since the discovery of plastic, we actually used it. We found its uses in so many areas in our lives. We see plastic everywhere. So in 2014, it was reported that worldwide plastic production reached 333 million metric tons. So just let that sink in. So, okay, let's move to the 4 R's now. Let's start with reduce. So, reduce, basically reduce the amount of materials used. For example, you use less plastic in the production of bottles. I know that recently, Summit, by the way, is a drinking water brand in the Philippines. It's very popular. Uh, their new containers are actually made from less plastic. So that's before learning this, I actually thought it was bad. It was worse. But it actually turns out to be better for the environment because you use less plastic, less processing energy is needed, less resources are needed. So, yeah, it's been mentioned here. Less polymer use, resources, that's the polymer. Less processing required. And at the same time, in a way, another benefit is that since the products are supposed to be lighter, shipping costs would decrease. So you could say that as well. Also, sustainable packaging, um, edible water bottles, although this is still being researched on. Leaf packages, this is actually actualized in Thailand. Uh, so yes, that kind of sort. Basically, use less plastic, if can be, and if it's practical, then just do it. So, reuse materials. You use your own bags at the grocery store, so that's one example. Next, recycle. Recycle materials. You don't throw beverage bottles away. Um, so again, to recall, plastics that cannot be recycled, we have polyvinyl chloride and polystyrene. So, um, although they cannot be recycled, well, we'll just good game, GG's. Uh, Although I know that's not the end for these kinds of plastics. They cannot be recycled, but I think if I recall correctly, they can be downcycled. What's the one that can be downcycled? PET. But it's not in this list. PET is not one of those that cannot be recycled. We can shred PET bottles. Sorry, by the way, I have to end this.